Hey now, what's up, internet people? We're back doing Code Katas. The one we are on now is are they the same? So what it wants us to do is we're given two arrays, A and B, and we need to write a function that checks whether the two arrays have the same elements with the same multiplicities. Same means here that the elements in B are the elements in A squared, regardless of the order. Comp A and B returns true because in B, 121 is the square of 11. 14,641 is the square of 121, 2736. So all the numbers in this array are a square of some number in this first array. Invalid arrays. If we change the first number to something else, comp may not return true anymore. Because B is not 1K. Okay, so we might get an empty array. We might get null or none. Okay, cool. So let's do it. Put our title in. Okay, so let's go ahead and start up Quokka. Okay, so now we're getting undefined returned because our code's not doing anything, but eventually we want it to return true if every number in this, every number up here, individually, if they're squared, it equals to one number in our second array. So the first thing we need to do, it did say that we could get passed in like null values, which means essentially means nothing. So we want to say if array 1 is equal to null, or if array 2 is equal to null, then we want to return false. And we don't need curly brackets. Okay, so we'll go ahead and check for that right from the get-go. The next thing we need to do is we need to sort our arrays. We're going to go through this array and square each number and then sort them after we've squared them. And then we will sort these numbers. And then we'll check if they're the same at each indice. And if they're all the same all the way through both arrays, then we know that we need to return true. So we'll let sort, we'll call it sort1. We'll let that equal our array, our first array. We're going to have to square all the numbers. So we're going to say array 1 dot sort. And our sort takes in A and B. And we want to sort it, we want to say A minus B. And that'll give us our numbers from least to greatest. And then we need to, we're going to map over each number. And we are going to square it. So we'll say num squared, like that. So that's going to square every single number and sort them. Okay. Then we'll let sort2 equal our array 2 dot sort, and that'll take in A and B as well. And we'll say A minus B, just like we did with the first one. So that's all we need to do to that one. So this gives us each of our arrays sorted. This one squares every value in the array. And then so what we need to do is we need to loop through our sorted array and compare it to the other array and make sure the numbers are the same. So we'll say, we'll create a loop. And while this is, while I is less than sort1 dot length, then we want to increment, so we'll do I++. And then we need to say, and we'll go ahead and let our, we'll say let number equal sort 1 at index, and that'll give us each individual number. And we'll say if number is not equal to sort2 at index, it's not equal to the number at the same index of our other array. Then we want to return false, because they're not equal, so we know that some value is not correct. So we'll go ahead and return false. And if it passes this test, then we'll go ahead at the bottom and just return true. We know that all the numbers are the same, right? So we're getting true returns here. So let's, what's it complaining about this for? I'm not sure. Okay, so let's go ahead and copy this. Let's put it in Code Wars, see if it works. Nice, passed that one test. And it passed all 54 tests, so that's cool. So let's go ahead and submit, see what everybody else did. Okay, so they did pretty much the same thing. They returned array1.map, squared the number, and checked if it's the same in array2. Cool. All right, let's keep going. Next is valid parentheses. So we need to write a function called, we need to write a function that takes a string of parentheses and determines if the order of the parentheses is valid. The function should return true if the string is valid and false if it's invalid. So how this is going to work is every opening parenthesis needs a closing parenthesis. So you see here it's false because one's backwards, one's forwards. If there's only one, we return false. This returns true. Each opening parenthesis has a closing parenthesis. Cool. Cool. And it says every input will be greater than 0 and less than 100. Cool. Let's go ahead and save this file, get rid of it, put our title in. Grab our code, our function. Grab our test. And let's turn these into console log, start up Quokka. Cool. So right now we're getting undefined returns. We want a Boolean value, true if it has valid opening and closing parentheses, false if it does not. You see this one right here doesn't have an opening one. So I think what we're going to want to do is we're only going to need to look at half of our string. So what we can do from the get-go is, let's say we'll go ahead and let length equal our parentheses that are passed in here, and they're called parens, and we want the length of it, and we'll just divide it by 2. So then we need to check it has an opening and closing parentheses. So what we're going to do is we're going to loop through, and while I is less than length, this variable we created up here, we're going to increment it. We'll say I++. And then we're going to say our parens, we want it to equal our parens dot replace. And what we're going to do is we're going to replace any parentheses that match, that have an opening and closing, we're going to replace them with a blank space. So we're going to say replace any parentheses like that, and we want to replace it with a blank space. So now we know if the string ends up being empty, then we know that they all had matches. So we'll say parens equals a blank string. So if parens equals a blank string, this will automatically return true, and if it doesn't equal a blank string, then it will return false. And you can see here that we're getting true and false values returned correctly. So let's throw it in Code Wars, see what happens. 2 tests passed. It's good. Let's attempt it. All 119 tests passed. So super cool. So let's submit and move on to the next one. Right. So this is cool. So if this is a good idea, so they have an incrementer, and if they come across one that's forwards, they increment this. If they come across one that's backwards, they decrement it. So if, at the end, if they end up with 0, then we'll know that it was a valid string. Cool. All right, cool. Convert a string to a number. So we need to make a function that can transform a string into a number. Don't worry, all inputs will be strings. Every string is perfectly valid representation of an integral number. So there's 1,000 different ways to do this. We're given a string, and we need to turn it into an integer. So let's go ahead and bring it down locally. go ahead and save this file, get rid of it. Grab our code, our function. Grab our test. Change these to console logs. Start up Quokka. So in order to do this one, all we need to do is we need to return our string, and there's tons of different ways to do this. We could just return our string like that, but what we need to do is we need to put a plus sign in front of it, and that will turn it into a number. So that's it. I mean, that will do it. You could also do it like this. We could say return number, and pass in our string. We could also say return parseInt, and pass in our string, and that'll do it also. I think there's some other different ways, but this is definitely the way that I always tend to use it. Just throw the plus sign in front of it. So let's check it out. Passed, submit. Did it. Easy peasy. So you can see this person used parseInt, this person used number, this person used the plus sign. This person just said number. I don't know how that works. Okay, cool. Let's move on to the next. Build a pile of cubes. I think I remember this one being a huge pain in the ass. So our task is to construct a building which will be a pile of n cubes. The cube at the bottom will have a volume of n to the third power. The cube above will have a volume of n minus 1 to the third power, and so on until we have a volume of 1 to the third power. So we're building like a pyramid. You are given the total volume m of the building. Being given m, can you find the number of n of cubes you will have to build? The perimeter of the function will be an integer m, and you have to return the integer, such as n to the third power, n minus 1 to the third power, and so on, if such n exists, or -1 if there is no such number that will complete it. Cool. So I think I know pretty much how we want to do this. We want to have a place to store our number in, and then we need to have a place to store our volume also. Okay. So let's bring it down locally. Hopefully this one works out. This one could get ugly. Let's open it up. Let's save this one. Get rid of it. bring our title in. Grab our function. And grab our test. Cool. Cool. Console logs, Quokka, you know the drill. Cool, so we're getting undefined returns. These are our values that we need to return. This is our input. This is our volume. So the first thing we're going to need is a place to store n. So we'll let n equal 1, and we'll need a place to store our volume. We'll let volume equal 0. Now, while our volume is less than our input number, so while our volume, is less than our input, which is m, then we want to say volume plus equals n, which is 1 right now, to the third power. Okay, so we're going to increment our volume, and then we need to say if our volume is equal to our input, then we need to return n. We're done. If not, then we need to increment n. And so we'll say n plus equals 1. Cool. And if all that doesn't, if it doesn't pass through all that, then we're going to go ahead and just return -1. And we know that we can't do it. So yeah. So that was easier than I thought it would be. So it's working, right? Yep. Cool. Cool. All right, so let's submit it. Let's test it. And let's attempt it. All 114 tests passed. Let's submit. Cool. So they created a place to store m. They said while m is greater than 0, then m minus equals n to the third power. They increment they increment n to the third power. And if m has a I don't know what's going on right here. This is how we did it pretty much. Cool. All right, detect a pentagram. So, a pentagram is a sentence that contains every single letter of the alphabet at least once. For example, the sentence, "The quick brown fox jumps over the lazy dog," is a pentagram because it uses the letters A to Z at least once. Case is irrelevant. Doesn't matter if it's uppercase or lowercase. Given a string, detect whether or not it is a pentagram. Return true if it is, false if it's not. Ignore numbers and punctuation. Cool. So, cool. Okay, so let's bring it down locally. Let's go ahead and say code. Bring it in. Let's go ahead and get rid of this one. And let's train. So first thing we need to do is remove all the punctuation from our string. It says to ignore punctuation and numbers. And we're gonna need to remove spaces also. So we're getting undefined. We need a Boolean value, either true or false. If it is a pentagram, true. If it's not, false. So this sentence here is being tested in this first one. It is a pentagram, and this one is not a pentagram. It does not contain every single letter of the alphabet at least once. So the first thing we're going to do is we're going to take our string that we're given, which are these right here. These are being passed in. And we're going to go ahead and make it all lowercase because it's saying that case doesn't matter. So we're not going to worry about it. So we're going to say string equals string dot to lowercase. Right? And that'll take our string that we're given and make every single letter in the entire string lowercase. The next thing we need to do is we need to remove spaces and punctuation. So we'll call it letters because that's all we want in the ends. Is just our letters left. And we'll take our string and we'll say dot replace, and we'll replace exclamation points, period, question mark, and we want to do that globally across the entire string. If we don't put this G here, it'll just do it, it'll find the first punctuation it finds and get rid of that one and then stop looking. So we need to do it globally. And we want to replace it with a blank, with nothing, just like a blank string. So that'll remove all our punctuation, but then we also need to do spaces. So we'll do another replace, and we will replace a space. And we want to do that globally also. And we'll replace it with same thing, nothing. So that takes out all punctuation and spaces. So the next thing we need to do is we need to get, what I think we're going to do is we're gonna look at the length of it at the ends. And the English alphabet has 26 letters. So if the length, if we remove all, we want to get all our unique values. So we're going to remove any doubles. So the way we're going to do that, I'm going to say unique, and that'll be a new set, and we'll pass in our letters. And what the new set does is it will remove any duplicates that are in the string. If there's two B's, it'll only return one of them. And so the next thing we need to do is we need to all we need to do now is we need to return our unique letters. We need to turn it into an array, so we'll use our spread operator, and that'll be unique. And then we need to return, we want the length of it, and if the length is equal to 26, it will return true, and if it's not equal to 26, it'll return false. And you can see here that it works. Cool. So we lowercase the whole thing, took out punctuation, spaces, took out all double characters, checked the length of it. If the length is 26, then we know it uses every letter in the alphabet, and we know that's a pentagram, so we return true. So let's throw it in Code War, see if it works. Cool, passed. Let's attempt it. One failed. Which one? Oh, we need to remove numbers as well. So what we will do, see, I think that's what it is. Oh, there's commas and there's numbers. So what we need to do is we also need to replace commas and numbers. So we'll do, how does the numbers go? I think it's, we say 1 through 9. Does that work? Let's try it. I don't think that's exactly the syntax. We might have to do a little Googling. Let's attempt it again. Oh, passed. It worked. Okay, so that's cool. So that took out the commas and the numbers as well. Cool. So let's submit it and see how everybody else did it, and I think we'll call it a day. Cool, so stringed out lowercase. They put the whole alphabet in there. That's definitely unnecessary. They split the alphabet and they checked every single one. And they checked if the letters matched up from the string to the alphabet. This is a lot of regex. I'm not totally sure what's going on. This is cool. Alright. Yeah, I guess that's enough for today. I hope everybody has a great day. Catch you later. Peace.